Hello, welcome back. This is the third video for the chapter 4.4. Now we are going to discuss the second type of intermolecular force that can be present between covalent compound, which is hydrogen bond. Okay, as usual, we have to know what is the meaning of hydrogen bond so that we can identify whether hydrogen bond present between the molecule or no. The hydrogen on one molecule attached to FO or N, fluorine, oxygen or nitrogen. So here we consider this is the first requirement. There must be a hydrogen, and then this hydrogen is attached to the FON. So hydrogen, FON. So try to remember hand font. Okay. And then this hydrogen at the same time will attach to FON of different molecule. Okay, so they must fulfill these two requirements that only the hydrogen bond are present between the molecule. So look at the diagram, maybe you will get a better picture. Okay, so if we look at here, this is the hydrogen in one molecule. This hydrogen is attached to FON. At the same time, this hydrogen also attracted to another FON. In this case is the oxygen, which is from another molecule. Okay. So this dotted line are considered as hydrogen bond. So this hydrogen attached to nitrogen fulfill the first requirement of the definition of hydrogen bond. Second requirement, the same hydrogen are attracted to the FON as well, which is partially negative. So the dashed line is the polar covalent bond because we can identify this is partially negative for nitrogen and partially positive for hydrogen. But then the dotted line between two molecules is considered as hydrogen bond. So basically again, we will need to know hydrogen bond is stronger or weaker than van der Waals force. So generally to say hydrogen bond is stronger than van der Waals force. Okay, this slide is actually just like a quick review only to recall back how the hydrogen bond can be formed. So again, hydrogen can be formed when in the molecule there is hydrogen which is directly attached to the fluorine, oxygen and also nitrogen. Okay, and then here, sorry. Okay, and then this hydrogen can form hydrogen bond with this nitrogen. So this is hydrogen bond. Okay, the hydrogen bonded to FON at the same time also attracted to the FON from another molecule. So here this is the hydrogen bond in between these two molecules. This one also can consider as hydrogen bond. Okay, now here we have 1, 2, 3, 4 and 5 group of molecules. So for example, we look at the first one, H2O, and then this is another H2O molecule. This hydrogen bonded to oxygen, and then it is attracted to another oxygen. So this red dotted line is considered as hydrogen bond. Similar cases also happen in between ammonia molecule. Okay, this hydrogen is bonded to nitrogen, and then again this hydrogen at the same time also attracted to FON. So this one also hydrogen bond. Okay, for the third pair, yes, we have a lot of hydrogen here, but this hydrogen bonded to carbon. This one also bonded to carbon. These three also bonded to carbon. These two bonded to carbon, and these three also bonded to carbon. So means that the first requirement is not fulfilled. And then we see there is oxygen, but the oxygen again also bonded to the carbon. So this oxygen also cannot form hydrogen bond. So first and second molecule can form hydrogen bond, while the third molecule cannot form hydrogen bond between the molecule. So 4 and 5, you are going to determine. Maybe we can discuss during the tutorial time. Okay, there are more exercises for you to answer. Try to select which of the following compounds can form hydrogen bond between the molecule. Basically, you have to draw the Lewis structure before you can identify. Okay, so I will draw one Lewis structure for you, which is this CH3, CO, and H2. Okay, so we may discuss the answer during the tutorial time. Okay, we will going to end this video with a quick summary, which we comparing the strength of the intermolecular force between the covalent compound. So the strongest is the hydrogen bond, followed by dipole-dipole, and the weakest will be the London forces. So why hydrogen bond is stronger than dipole-dipole? So for your information, I think you already know that there will be FON. Then these FON are the most electronegative element in the periodic table. Okay, so and then just reminder again, for example, H2O, because just now we already identified there is hydrogen bonded to oxygen, and then at the same time the hydrogen also will be attracted to the oxygen from another molecule. So that's why water can form hydrogen bond. But don't forget, at the same time, dipole-dipole forces also exist between the water molecule, because there will be one part hydrogen is partially positive and then oxygen is partially negative. This is permanent. And also London forces also present at the same time, as we already know that all molecule consists of London forces between the molecule. So for this video we are end here, and then next video we will discuss about the strength of the hydrogen bond. Thank you for your time. See you in lecture.